Let me know when this thing dings. There we go. Okay, so today I wanted to talk about what happens when your two curves intersect at more than 2 points on the interval that you're trying to calculate the area between two curves, right? So let's say I was asked here to find. Let's do one real quick. Let's have this as a example right here, and we're looking to find the area, right? Find the area of the regions bound by the graphs of, and let's go here, we got f of x, and f of x is going to equal to 3x cubed minus x squared minus 10x, and g of x, and g of x is going to equal to negative x squared plus 2x. Okay, so we got two graphs here, and we're just looking for the area that's bounded by these two graphs right here. So just for the sake of time, I'm going to graph this out using Desmos, and then I'm going to go ahead and show you what we're going to do after that. So let's go ahead and graph this real quick. So let's open up Desmos over here. Those two functions that we have, right? F of x is going to equal to 3x cubed minus x squared minus 10x. That looks something like that. Let's zoom in a little bit there so we can get that going. And then g of x is going to be right here. Let's go g of x. Let's do that in blue, and let's make g of x equal to negative x squared plus 2x. Like that. So let's see here. Let's adjust our window so it looks a little bit easier to deal with here. The x-axis, I don't need to go all that far out. I can just go to like, not -9, let's go to like -4, let's say. And then for the positive axis, let's go up to like, since we're going to -4, let's go +4 like that. And then the y-axis, do we need to adjust that? I think that looks good, right? That looks pretty good, right? We can see the two graphs here. I'm going to go ahead and screenshot that and put that into our notes right here. So yeah, ideally they'll give you the graph with those functions. If not, then hopefully you're on the calculator section. You can graph it that way, and if that way you can kind of visually see it, right, where these two functions are intersecting. Let's go ahead and get that in here a little bit smaller so we can fit that with the problem. So we have here, right, our two graphs. Hopefully you guys can see it. The red graph. Come on, OneNote. Why you got to do this to me now? There we go. So the red graph, right, is this one right here. And then the blue graph is your g of x right there. So you guys can see the region, right, that we need to calculate, right? The region that's bound by these two graphs right here. Hopefully you guys can see it. Here's the first region, like so, right? And here's the second region, like so. Now what we need to do is to kind of find out where those points intersect. Now, if the function crossed like this and the top function remained the top function all the way through, right, we could have just did the integral, right, from wherever it starts to wherever it finishes. But since it switches like this, we're going to have to do two regions here, right? We have to do two regions. We have to do the one that's on the left plus the one that's on the right. That's how it's going to have to work out, because the one that's on the left, the red function, the f of x function, is on top, right? Whereas the right function, g of x, is on top. You see that? G of x is over the other function. So on this one over here, this will be g of x minus f of x, right? And then the one on the left will be f of x minus g of x. Now, my only issue is I need to figure out where these points are. Okay? I need to figure out where these points are. And I can kind of see it based off of this graph, right? That this is going to be at -2 right here. This is going to be at 0. And this is going to be at +2. But if they gave me, let's say, a graph and it wasn't like, didn't have all those points there for us to easily see what they were, how could I algebraically find out where those points are? Does anybody know? How could I find these points here that I just drew right here? How could I find these points algebraically if I didn't have it. Solve. Now, what am I solving? That's the big question here. How do I solve to see where these points are? What's the equation I need to write out? Solve for x. I have an f of x here, so I have 3x squared minus x, 3x cubed minus x squared minus 10x. What do I need to set it equal to and then solve for x? Set both equations equal to each other. That's right. You're looking for when g of x and f of x equal to each other. That's when they cross each other, right? That's when they cross each other. So set that equal to this one. Set your f of x equal to g of x. And then, just like Monica was saying, solve for x, right? When you have these polynomials, it's kind of easier to set it equal to 0 and hope that it has the zero product property that you can apply. So let's go ahead and double check here. Adding the x squared to both sides will cancel out your x squared. Subtracting the 2x to this side, you're going to end up with 3x cubed minus 12x equals to 0, which you could factor out a common factor of 3x. You're left behind with x squared minus 4, which is a perfect factor, a perfect square, which will then factor out to x plus 2, x minus 2, which leaves you with these three particular values for x. X equals to 0, x equals to -2, and x equals to 2, which happens to be those points. Okay? With that being said, now that you know those points, or you know how to find those points, right, to calculate the area, right, the total area, right, like I was saying, is just going to equal to the area of the left region plus the area on the right. Now, the first one, the left region, right, I should have done this in a different color. Let's do that in yellow, and let's do this one in green so we can see the difference between the two here. So if I'm looking for the area on the left, right, this guy right here, all I'm going to have to do is take the integral from where does it start to where does it finish. And it starts at -2 to 0, right, from here to here. So -2 to 0. I said -2, knock me, and you still wrote 0. I know. So it goes from -2 to 0. And on the left side, the top function is f of x, right? The top function is f of x, which is 3x cubed minus x squared minus 10x, right? Like so. And that is going to be subtracted from g of x, which is -x squared plus 2x. This whole thing right here, dx. This whole thing represents the area that's shaded in yellow right there, right? Hopefully you guys have that down right. This is your f of x. That's the wrong color. This is your f of x being subtracted from your g of x. And again, it's that concept of like your top function minus your bottom function, right? And hopefully you can see it, right? G of x is on the bottom from here to here, and f of x is on top from there to there. That's how we figure that one out. And then we just have to add that to the other area, right? We just have to add that to the other area. The other area is going from 0 to 2, right? From 0 to 2, that's where the last region is. And the top function there is going to be the g of x function, right? Which is going to be -x squared plus 2x, right? Minus, and then we do that with f of x, which is 3x cubed minus x squared minus 10x. This whole thing, of course, dx. And this is going to represent that whole area, that whole region to the right there. And again, pay attention, right? This is just g of x minus f of x. That one right there. Okay. Now it just becomes like a straight up just integral problem, right? Pay attention to pay attention to the signs, by the way. This is a common mistake when people do these integrals. They always mess up on this distribution of this negative sign. This negative sign needs to go to both the x squared and the 2x. So this right here is going to become the integral of -2 to 0 of, looks like 3x cubed, right? 3x cubed, -x squared, positive x squared cancels out, -10x and a -2x is going to be -12x. That's what that simplifies to dx. Plus the integral from 0 to 2 of -x squared minus -x squared is going to cancel each other out again. Over here, I'm going to have over here -3x cubed plus plus 12x, right? The negative right here distributes to here, here, and here. That's going to be a positive 10x plus 2x is going to be plus 12x dx, right? And then from here, it's just a simple power rule. Integrate both integrals right there. Pay attention to the evaluating the values to evaluate with. So right here, we're going to have here, this is going to be, careful with this one, this is going to be x to the fourth is what it becomes, divided by 4. But of course, there had a 3 in front of it still, so it's going to be part of that right there. So it'll be 3x to the fourth over 4 minus, I believe, 6x squared, right? If I do the derivative there, 2 times 6 would give me that 12. Okay, so this right here is going to be evaluated from -2 to 0, plus this one over here, which is going to be this one again. Shoot, let's see here. Negative 3x to the fourth over 4, right? Plus 6x squared, evaluated here from 0 to 2. Okay, then we have to plug in those values and evaluate it out. Let's do that real quick. Over here, if I plug in 0, I'm going to get 0, of course, minus 0. Hopefully you guys are okay with that. Minus, I'm going to plug in -2 over here. This will be 3 times -2 to the fourth over 4 minus 6 times -2 squared. That's what that one's going to be. Plus, this one over here is going to be -3, 2 to the fourth over 4 plus 6 times 2 to the second, whatever that's going to be, minus, and then when I plug in the zeros, that's going to give me a 0 there, and that's going to be the 0 right there. Okay, so evaluating this out, let's see here. This whole thing is going to be equal to 0. So it's going to be, let's see here, -2 to the fourth is going to be, what is that going to be? 16? Yeah, that'll be 16. 16 times 3 is 48, if I'm correct, right? So this should be 48 over 4. This right here will be 4 times 6 is going to be minus 24 right here. So when I distribute this negative sign, this is going to come out as -48 over 4 plus 24. That's what this one's going to be. Over here, this is going to be plus a negative, I think that's going to be 48 as well, over 4. Yeah, 48 over 4. And this one right here is going to be a plus 24. Did I do that right? I think that's right. Yeah, I think that's right. I should have rewritten this, though. This is 48 over 4. Why am I writing it as 48 over 4? That's just -12 plus 24. This is -12 plus 24. I believe this simplifies out to just 24. Did some weird math with those fractions there, but that's what that's going to simplify to. So that's what that area is going to come out to be. Okay. So area between two curves. Are you guys okay with this idea? It's just top minus bottom. You're still doing integrals, right? That whole thing we did on last chapter was all integrals. So you learned all these integral rules. Now you're going to get like different types of curves, and you just have to understand like which function is on top and then subtract that from the bottom function. And then once you get that down and you just calculate those integrals, you'll have the area between two curves. That's it. That's it in a nutshell. With that being said, I forgot to put up the homework for this last week, I think, right? Did I not put up the homework? I don't think I did. Yeah, I did not. It's okay. It's not okay. It's okay. I'll put up the homework. Let's do that right now before I forget. So I'm going to wrap that up right there. Let's go ahead and put up the homework. Oh, I don't have the pages ready. That's why I don't have it. I have to get the PDFs of them, and then I can look it up. Okay. Okay. I got lessons to do today. Anyways, I have to figure that out later. I'm going to go ahead and stop the recording here, and we're going to end the lesson here. But before I let you go, a few heads up. Let me stop here.